Hello everyone and welcome back to the channel. In the previous video we explored the basics of number system including how to convert between binary and decimal to binary that formed the foundation. Now in this video the playlist we are taking in a step further. Today we will dive in deep more into the important number systems used in digital electronics. The octal system base 8, the hexadecimal system base 16. They are especially useful when working with the long binary numbers. We will clarity discussed what is meant by octal, hexadecimal as well. On we will relate to binary, and importantly, we will convert between binary, octal, and hexadecimal. The conversions are very important, and with those conversions, we can get a more clarity, so that we can able to interact with the how we have to convert between those two. So let's start with octal. Bit to the base 8 means 2 power 3, 2 cube. So basically all deals with the 2 power n means 2 cube means octal, 2 power 4 means hexadecimal. So like that, so first we will see the octal. Octal means basically 0 to 7, that is known as octal. So 8 digits, so 0 to 7 as you're seeing there. So then we can able to compare with the 0 to 7 as with binary numbers as well. So it is basically from 0 to 7, 000 to 111, that is in decimal form to binary form. Yeah, the representation of the octal numbers is somewhat like this as shown in there. So in the brackets outside we have to write as representation a small suffix like 8. So if you see or consider the example, so 70, so 8 110 243.445, like that. This is a simple representation of the octal numbers. Now let's start hexadecimal. So basically we have already seen what is meant by octal. So octal means 8. Let's complete it. So hexadecimal means 2 to the power 4. That is 16. 16 means hexadecimal. Basically we have to start with 0 always and end up with getting the last. If in this case we are starting with 0, so we have to go to up to 15. But double digits are not allowed. So we have to go 0 to 9. So 10 digits completed. So after 10 digits we have to start with a new digit, that is capital A, B, C, D, E, F. So we have to go up to F because that is 15. F is 15 in hexadecimal form. And these are the equivalent binary digits of hexadecimal digit in. So it is 4-bit form. It is in the 4-bit form from 0 to 9. Those are represented in binary form also. And A to F. Those are represented in hexadecimal form as and binary form as well. But F is very important. That is 111. That is 15 in decimal. If you consider the representation of the hexadecimal, it is somewhat similar as octal. So if you see there, in the outside of the brackets, we have to write as 16 as notation. So if you see there some of the examples, you can see 20 and after brackets you have to represent that 16. So if you are representing as 16 outside, it is hexadecimal. If you are representing 8, that is octal. 2, that is binary, and 10, that is decimal. So as we consider, there is only binary, the main thing. So why we need octal? Why we need hexadecimal? So we already know the use of decimal. Decimal means a normal digits that we use daily. So binary can be understand by only computers and or electronic devices can understand only binary. Then what's the role of octal and hexadecimal as well? Now we are going to discuss these 8 types of conversions and their use, why we are converting to hexadecimal and the octal. So first we will be going to discuss the top 4 conversions. So those are very important and very easy. So that I have started with these top 4. So that is basically binary to octal, binary to hexadecimal, and vice versa. The binary to octal conversion and the binary to hexadecimal conversion is very easy as compared between octal to binary and hexadecimal to binary, because we will be going to discuss these two easy tricks first because we have a trick to convert. So first let's start with the binary to octal conversion. So let's see the example 101011. So we have to convert this octal means 8. We have to convert to binary to octal. So that there is steps. So we have to follow the steps that to get octal. So let's read what are the steps going to do. So split into groups of 3, if not possible 3, then add 0. So this is the first step that we need to going to do for the conversion of binary to octal. Then simply express the 3 binary digits as decimal equivalent. So let's see what is meant by that. According to the first point, 33 highlighted 33 means see there. So 101011 has to be divided as parts of 33. So then we know how to convert a binary to decimal. So according to their they are given binary. So 101 means 5 in binary decimal. 011 means that is 3 in decimal. So just simply convert those two groups into decimal form. Then the resultant would be the octal form, right? 8 as suffix after the brackets. That's a simple conversion. So that's why I am saying it's easy. So same like this only. From binary to hexadecimal also very easy. So for the more clarity, we would be going to solve more three questions. Though to convert to octal, it is very important and easy as well. So if you see the first example, that is triple one. So basically we need a three of a group. So there is three, it's enough. So make a group and triple one is a 7 in decimal. So simply write and convert it as a octal form. So the point will not make any sense. So just convert those two groups as 3 and simply write as 3.6. So that's it. And if you got only two ones, then it's an important case. Add a zero at end. After point, add a zero after the last binary. But here, there is no decimal point. So we need to add zero at end. The resultant would be 3 as octal. As you see, as we converted binary to octal, the similar way, the same way we have to convert binary to hexadecimal as well. So the example is same, but we have added some more digits. So the definition is also same. Split the groups into 4, 4. We have to make a groups of 4, 4, and we have to represent from 0 to 9 and A to F. The representation that has to convert it from the corresponding binary hexadecimal form. That's the representation. With this, what is the importance of hexadecimal? So above examples of octal and hexadecimal, we have understood that. So the length is more. If a binary digit of 100 length, we can split into parts. So we can split into 25 parts and we can able to merge easily one by one. So the length of the binary digits is reduced of 4444. So it is very easy to understand or read the big length. So I can able to explain the importance of hexadecimal and octal. So hexadecimal and octal coming to picture because to compress the binary digit length 101000001 like that, so on, like that a very big decimal, so like a binary number has to be minimized. So that minimization can be happened or occurred with the help of hexadecimal or octal. We have to minimize in hexadecimal with 4 and we have to represent in hexadecimal form. So in the top four, we have categorized all the conversions into 8 conversions. So in the 8 conversions, in the first 4, we have converted all binaries. So in the second set of 4 conversions, we have converted into decimal and that kind of conversions. So in the first 4, we have completed from binary to octal. So this is vice versa. That is octal to binary. So first let's read the statement, how to convert. So first convert the octal to decimal, then simply convert the decimal to binary. So by seeing this, don't be confused. Let's understand with an example that given below. So here is an example for you. So the question is convert 41 to a binary. So this is a simple question. So we have to convert 48 into binary, simple 2-bitted 0 or 1's format. For that, we need to convert 48 decimal form. Why we need to convert into decimal form? We will be going to see in the next slides the importance of converting. It's an easy process. First, we need to convert to decimal to binary, because we know the conversion by decimal to binary. So it is easy. The step 2 is easy. The violet highlighted part is easy. So the different part is from octal to decimal that we are going to do in this part. So solution is down on. We have to convert octal to decimal. That is easy only. So we have to. So we know the formula that we have seen in last video. So last video of the playlist, the previous one. So if you see that we have to convert like 8 power 0, 8 power 1 has to be multiplied with the corresponding individual digits, and we have to add them up. So the corresponding digit, the final digit, summed digit is the output that is in decimal form. So if you have still confusion, the formula also can be recalled from here. So if you have octal digit, you have to convert into a decimal form. So we need to multiply. We have an example of ABC. So we need to multiply with A to 8 square, B to 8 power 1, C to 8 power 0. This is like any case. So we binary into decimal. So the same formula can be applied. That is also shown in the below. So that is ABC decimal. So it has to be converted into decimal. So we need to multiply with 2 power 0, 2 power 1, 2 power 2. Basically, what is the suffix and what is the number system? We need to use this formula or this format to obtain the decimal number. So in the previous lecture, we have discussed how to convert a decimal into binary format. It is a very easy process by using the formula, not formula, it's a trick. So now in this lecture, we are going to see the actual formula or the actual format to convert a decimal into binary format. or any format. So let's see the second point. So second point says now convert this decimal number into equivalent binary. So this is the actual method. So let's see. So I have represented this as a table wise so that you can able to compare, and it's very easy process also. So let's see. In the previous slide we have got 33 as our final decimal form. So we need to convert that 33 10 to 30 or hyphen brackets 2. So you need to convert. So for that we need to divide 33 by 2. So we have to divide and until we get the required one or the 0. First 33 is divided by 2. The remainder is 1. The quotient is 16. So next time we will be going to divide the 16 with 2 and we are going to obtain the remainder as our output. The last quotient, that is 16, is divided again with 2 and we are getting the new quotient 8 and the remainder 0. So we have to note that all reminders. So it is very important. Reminders are very important because those are only the our required binary numbers. After that we have got 8 is divided with 2. So 4 is quotient and 0 is remainder. In the previous remainder 4 is divided again with 2 and we will be getting 2 as remainder, sorry, quotient as 0 as remainder. Remainder is very important, again I'm saying. So we have to note all the reminders down way. Same way 2 is divided with 2, our quotient is 1 and remainder is 0. So we have to stop this the last case because we are getting 0. Sorry, we have to get another case because we are getting 1. So let's see the next case also. As I said, we have another case. This is the next case. The next case is we have to put 0 even though it is not divisible, I know, but we have to put 0 so that we will be getting 1 as last out. So for that, so we have to trace from down way to up as of all reminders. So that is our or the decimal converted binary. I think you can able to observe how we are going to write all the reminders from bottom to top as shown in the table. So we have that 48 is represented 1000001 in the binary form. It is very simple, the division and writing as a table and writing below. So they're written also in purple highlighted way. Take from bottom to top. So that is thing. So as the last video shares, the shortcut also written there. We have to write all the 2 power 1 started with 1 and right we have to 2 power increment 2 power 1 2 power 2 2 power 3 2 power 4 2 power 5. So what we have to add to get the sum of 33? So that is 32 and 1. So put 1 ones there and remaining all 0. So that is our final output. We can able to confirm with that also. So this is the last one, offset of first 4, that is hexadecimal to binary. So first convert hexadecimal to decimal and then simply convert decimal to binary. So this is the exact process that we have followed from octal to binary as well. So let's see an example so that you can able to clarify more easily. In this question they have asked convert a to b to a equivalent binary number. So let's see what same process, same method, same, all will be same. So you can able to relate the formula of the any hexadecimal or any octal has to be first converted into decimal. So we have seen the formula that we need to multiply to the base powers and into the individual digits inside it so that we can able to get the decimal form. So according to the formula only, we are going to write a to b 16 terms of powers like 16 power 0 1 2 in the product of inside terms and summing all. So if you summing all, if you do all, so a means 10 decimal form. We know that because so we will be ending with 0 to 9 and the 11th one, that is 10 completed. 0 to 9 means 10. So the 11th one is a, that is 10, of course. 10 means a, so 15 means f. So like that. So in the starting video only we have discussed what is meant by hexadecimal. If you have any doubt, you can go the previous and you can watch and come back here. So if you observe, so we can get sum all as 2063 as decimal form. So again we need to convert this decimal to binary. We can able to see with simple format or we can able to do that division process. But here it is a very large number, so we cannot do that shortcut method because in shortcut we have to write starting with 1 2 power 1 2 power 2, like that we have to write so on, and we have to compare what is the sum of all 2063. So what will be summed to get 2063? It's a very difficult process, so we have to follow the formula method, the division method, to get the decimal to binary equivalent. So as in this process, shortcut is not allowed, not easy. It is a very big process. We have to write a big powers, so that we are choosing this division method, a formula method. So that is 2063 is divided with 2 continuously until we reach the required one. So we are noting the reminders. So we have to write from the down to top or bottom to top. So that is our final required answer. That is A to B 16. 1 0 1 triple 0 1 0 1 0 1 1. It is in binary format. So see, these many digits or these many binary numbers, 12 binary digits is simply written in 3 hexadecimal form. So you can able to compress the 12 format to 3 format. So it's a very simple or very understandable way, and it is a very data saving process, so that we are able to represent, or we are representing the binary form in hexadecimal form. For the larger and complex, the length of the binary system is more, we are representing in this all. So we have successfully completed top 4. So successfully completing top 4, we now start the bottom 4. So I hope you understand top. If you have any confusion, watch it again, try to make notes and try to understand by your own, and that we are going to discuss in the coming lecture. So these four are also important. So if you know the main thing, the main concept behind that, you can able to compare any number system to any number system. Not only this, not only to the base 10, not only base to the 16, we can able to compare anything. If you know the formula, if you know the procedure to convert, how to convert. Indirectly, we have converted that octal in the conversion of octal to binary. So in the octal to binary, what we have done, simply we are converted that octal to decimal. So after that, the step 2 is we are converting decimal to binary. So we have completed two. Additionally, indirectly, we have completed those two, because in the upcoming means the completed lecture to now. So we have saw that is a two method process. So in the two method only, this is the half method, octal to decimal and hexadecimal to decimal. This is the half process in the way. So we are left with still only decimal to octal and decimal to hexadecimal. So we will be going to see these two also. So these two are left. Those are decimal to octal, decimal to hexadecimal. So these two also we will see now. So there is some point that you need to know. So for the conversion. So I read the point, listen carefully. So for both of these conversions, we need to divide the given by the base of the required number system. So that highlighted part, I'll read once again. Listen carefully. Divide the given by the base of the required number system. So what is this? So let's see with an example after. So let's continue the statement. So after this statement completed, let's see the examples, so that you can able to understand what's the conversion, how to do. So and continue this process until you get the desired number and obtain all the reminders from the bottom to top. So this is very important. We need to take from bottom to top always. So that is very important, and this is the required number system. So in this case, we have to divide 8 and 16 to get octal and hexadecimal. So the formulas, so the division method we have to follow here. So anything we need to follow two methods only there. One is division method is very important, and shortcut method, that's it. So let's see the first conversion. It's an example. The question is convert 1792 into an octal number. So without giving the brackets after 10 also, we can able to observe, because that's a normal number. So we can able to write brackets after 10 also. So both are same. That is decimal form only. So we need to convert to the base 8. So we are going to see how to convert with a division method. So the same, I am going to follow the division method only. So for that, I need a table. So as you're seeing there, so we have given that 1972 as decimal, so that I am dividing with 8. You can get it out. In the previous question, the top question in the previous one, you have divided 2. So why you are dividing with 8? So basically a general question. So basically in that we are getting, so in that previous one we are converting. So we are converting decimal binary, that is binary. So here this is decimal to octal. So octal means what? 8. We have to divide with 8. So the required one. See the statement once again, the previous state. So we have to divide with the required one. Dividing, we will be getting with one question and one reminder. Note it down both of them as shown in the table. So reminders very important. We have to write from bottom to top, so that you can see. So take the previous output, that is 224, and again divide with 8. So now take the 28 and reminder 0 as well, and note it down in the table. So same, repeat the process. Take the 28 and obtain, divide with 8, obtain reminder and question. So reminder is 4. Wrote it down in the table. So yeah, because this is octal. Octal means what? 0 to 7. Anything is possible. So no need of only one. Anything can be in the final out. Without taking means top to bottom, I am directly including in the table itself. The octal column is that only, the final output only. That you can able to know that in the last out, you can take directly last column. That is the last column, the 3400. That is the final out. Why? That is because that is only reminders. We are going from top to bottom. So in this we are getting reminder as 3. In the previous one we are getting reminder as 4. So if you go from bottom to top, So the previous column or the previous column, if you see that we go from bottom to top, we can see that only 3400. So that is the same thing that I wrote. So I hope you understand this conversion. This is the final one in the conversion. So that is decimal to hexadecimal. So the same process, the division method we are going to follow. So the question is 49 is a decimal. We need to convert to hexadecimal. So the same division method. So we need to divide 49 with the help of 6. So that note down the remainder and quotient, and the remainder value is hex value. We have to take from bottom to top. So that is shown in the table as well. Take a step ahead. So in the previous case, we have get 3 as quotient. So divide 3 with the 16 as quotient. So quotient we will be getting 0 and the remainder we will be getting 3. So the 3 is one of the answer. So we can be able to get 3 because hexadecimal means what? From 0 to 9 and A to F. So we can get A's and F's also in this, not a problem. So this is only final answer as you are seeing there. That is 49 in the decimal and 31 in the hexadecimal form. So thanks for watching this lecture. Do let me know your suggestions or your doubts or queries. If you have any queries, let comment down below. I will definitely answer your doubts.